share the video, so that stream. So, okay, let's get started. So today is my great pleasure to present to you Gareth Tyson. He's our speaker for the today's seminar. So Gareth is a senior lecturer, which is equivalent to associate professor at Queen's Mary University of London. And over the past few years, he did some fascinating work on internet measurement and data science. And over the past few years, he also received numerous best paper awards, like best paper at DubDubDub, Infocom, and so on. And today he's gonna talk about his recent work on how people are using and misusing WhatsApp. And Gareth, please take it right away.
Cool. That introduction was perfectly timed because I just had a coughing fit, so it covered it beautifully. Cool. Thanks very much, Savas, and thank you very much to you and your team for inviting me to do this talk today. So as Savas said, my name's Gareth. Nice to meet everybody. And I'm a lecturer at Queen Mary, and I'm also a fellow at the Alan Turing Institute. If you've not come across this second affiliation before, it's basically the UK's Data Science Institute. So if you're ever visiting London, do drop me a message because we're always happy to accommodate visitors and give them free coffee. Anyway, what I wanted to do today is talk a little bit about the research that we've been undertaking on the WhatsApp platform, how people have been using it and how people have been misusing it. I'll say in advance, this is the first time I've done this presentation, so it's not well polished. So if anything doesn't make sense, feel free to interrupt at any point, just unmute your microphone and shout out. I'm always happy to take questions or clarifications. Before I start, I should probably also give a shout out to some of the other people on the work, like Kiran Garamella at MIT and Nishant Sastry at King's College, who have been doing a lot of this work. And of course, Pushkal and Aravind, who have actually been the students doing a lot of the technical work as well. Okay, so see if I can move on. Okay, so if I was to ask you guys what you think when you hear the phrase social media, I think there's probably a fairly high probability that many of you would start spitting out logos like this. So, you know, Instagram, Facebook, Twitter, YouTube, and the like. Now, you'd be completely right. This is a large fraction of social media, but actually, this only covers a minority of online communications. And there are a lot of other platforms that researchers have paid very little attention to that actually facilitate a vast, vast portion of online interactions today. So you can probably guess what this is leading towards. So if I was to do a straw poll of how many people in the room use WhatsApp, I can turn my camera on. Just wave your hands if you do. Okay, well, from the cameras, I can see at least 100% of the people with cameras use WhatsApp. And it's absolutely true. So WhatsApp is huge. It's one of the most popular social apps in the world. It has over 1 billion users each day and over 5 billion downloads from the Play Store on Android. And the latest estimates I saw put it around 60 billion text interactions per day, which when you think of it is pretty insane for a platform that's received very little attention. So this is a visualization of the top apps per download in the world. And what you can see is, let me just get my laser pointer. What you can see is that in certain parts, like the UK, France, and most of North America, Facebook wins. So Facebook's the most frequently downloaded app. But actually in vast portions of the rest of the world, WhatsApp is top. And this is particularly the case in more developing regions like Africa and South America. So to focus so much energy on platforms like Twitter and Facebook, ignoring platforms like WhatsApp likely gives you a very biased understanding of how people are interacting. And as I say, it's barely studied despite this ubiquity. And interestingly enough, I think this ubiquity brings a bunch of opportunities and a bunch of risks, which, because we've not really looked much at this platform, we've yet to understand. So for some of you who may have come across WhatsApp in the news, you may also notice that there are notoriety of uses of WhatsApp, which have got a lot of negative media attention. So just to give you a couple of examples here, you may have seen recent research looking at fake news on WhatsApp and how it's disseminated in places like Brazil to promote certain viewpoints in the elections. Over here, you can see an article about how WhatsApp has been used to promote extremism in Germany. And actually, really worryingly, in other parts of the world, you see examples of where WhatsApp is used to coordinate physical attacks, where, for whatever reason, certain people disagree with the political stance of somebody, and WhatsApp is used to spread basically misinformation about that person to facilitate violence against them. So WhatsApp is not just this innocuous app being used to arrange pub visits. It's actually being used to do far more sinister things as well. So just to give you a quick idea of what I'm going to talk about during the rest of this presentation, I'm going to kick off talking a little bit about how we can use WhatsApp to collect data, because for many of you, this might not be something that you've come across before. I'm then going to focus on a particular case study. So we've done some work on other case studies, and I'm happy to answer questions on that, but I'm going to focus specifically today on spam dissemination in WhatsApp. And finally, I'm going to talk about some of the techniques that we've been developing to try and counteract this type of abuse of messaging platforms. Okay, so let's kick off with the first element, which is data collection on WhatsApp. And I focus on this particularly because for many people, they wouldn't have seen much data collection going on these messaging platforms. So the reason for this is getting data from platforms like WhatsApp is quite tough. So about 80 to 90% of all the messages are unicast. So they're direct messages between two people. There's no APIs that allow you to control WhatsApp or access data from it. And end-to-end encryption even prevents Facebook from gathering data. So this begs the question of how we as third-party research even think about starting to gather data on WhatsApp. Now, the first thing I want to emphasize is that getting private WhatsApp messages is not feasible and it's not desirable. So the rest of this presentation, I am not going to talk anything about collecting private or unicast messages. Okay, so I just want to make that very clear from the outset. Another thing, however, that WhatsApp supports is groups. And this is something I'm going to be talking about today. So to give you an idea of what a group is, this is the traditional form of messaging, right? You've got Alice and Bob, and maybe Alice sends a unicast message to Bob. If you want to create a group, however, you have a third party in, let's say John, and whenever one of them they get forwarded to everybody. So you have this group-based communication. So the way WhatsApp groups work is fairly simple. You can create a group with a brief name and a logo, and it gives you a unique URL. And that unique URL can then be shared with people who can click on it, it loads up the app, and they'll be able to join that group. Now, this has spurred a huge number of public WhatsApp groups whereby people create these groups and share the links publicly so anybody can join and start to interact on a given topic. And to enable this, a bunch of websites, which are essentially search engines for groups, have arrived, where you can go onto them, you can announce the availability of your public group with some metadata, and anybody else can come along and search for it, maybe searching for things like politics or sports, find a group of interest, click the URL and join it. And as I say, there are a number of these websites and you can take any one of them. So the next question is, now we know about these public groups, can we go about trying to collect data from them? So there are several options you could undertake to try to start collecting data from WhatsApp. So an obvious one would be manually. Another one would be to use the web WhatsApp interface, which is basically a browser version of WhatsApp. Another one would be to root your phone and try and extract from the database. And another one would be to try to take a jailbroken version of the WhatsApp app and use that. So each of these have different pros and cons. So the manual approach, obviously it's fairly straightforward to get started, but it's super boring. And it's going to take you a very long time with hundreds of grad students sitting there collecting manually one by one. So web WhatsApp is actually kind of nice because it gives you a nice platform which you can use something like Selenium to instrument the access. But from our experiments so far, it's been fairly unreliable. So even though it works for a while, it will crash, it will break, it will miss messages. So it's not really the best approach. Rooted phone, slightly better. But of course, if you're a poor undergraduate student trying to use this for their project, you don't really want to brick your phone. So there are risks that come with that. And last but not least, you could use this jailbroken WhatsApp version, but you're not developed it yourself, and probably you don't want to be installing this type of stuff on your device. So we tried all of these different variants, and we actually finalized on using a rooted phone. And this seemed to give it the best balance between simplicity and actually reliability. So how does it work? Well, very simple. The first step, you can obtain a public group URL. And probably you want to focus on a particular topic, so you'll try to get several groups that represent what topic you're interested in. So this can be done through a variety of means. One of the ways that we used was these public listings, where you go to websites that index public groups. Another popular approach, I think Savas has used this himself, is to use search engines of social media, where you can simply search these platforms for the chat.whatsapp.com domain. And essentially all of those are going to be group URLs, which you can join. But often what you'll then want to do is somehow manually filter them, because as I say, typically you're interested in a particular topic. So you want to focus in on, let's say, politics groups. So you'll take all these groups together and you'll filter them down to the ones that you're interested in. So once you've done that, you can start joining the groups. To do this, just create a dedicated WhatsApp account and run one of our scripts. So if you're interested, we've got the GitHub link at the bottom here. You can click that, and all the scripts that we're talking about today and also the data is available there. So basically our scripts are Selenium based, and they work with the web WhatsApp interface to take a list of URLs and join them one by one. And that's fine, because I mentioned earlier that it was a little bit unreliable, but typically you're only joining a few thousand groups. So that can be done in a pretty robust fashion. Now, once you've done that, obviously, messages will start to come through. So if you were to pick up your phone, which the WhatsApp instance was installed on, you'd start to notice a big bunch of messages flooding through there. So the next challenge is, how do you get those messages off the phone onto your compute server so you can start analyzing the data? So we've also provided a script for this, and all it does is it extracts the data from the SQL database on the device. If you try to do this by just going through the file system, what you'll quickly find is it's encrypted. So the scripts also decrypt the data for you, and that's actually why the routing is necessary. And once you start playing around with it, you might start to see a few interesting things you could look at. So for example, you could look at the text content of these groups. So this is an example word cloud from some of the groups that we were collecting. You can also look at the group metadata. So you can look at things like the number of messages sent in groups, or maybe the number of users participating in each group. Because they contain phone numbers, you might also want to take a look at the geographical distribution of users, because those phone numbers give you the area codes of which countries the users are situated in. And last but not least, you might also want to take a look at user behavior, because the data you'll be getting includes information about how people arrive in the groups and how they leave the groups. So there's some interesting stats you can look at related to those activities. So we've been doing this for quite a while now, in fact, a couple of years. So what I want to move on to do is to present one case study of the type of stuff that you can do with this WhatsApp data. And the particular thing I'm going to look at is the dissemination of spam in public WhatsApp groups. Now, we all know what spam is. It's unsolicited and unwanted messages sent out in bulk. All of you would be very familiar with receiving these via your email accounts. But what you might be less familiar with is the bulk distribution of spam via WhatsApp groups. And this is precisely what I wanted to focus on in this study. So as I say, spam is unsolicited and unwanted messages. And for everything else, we're going to be referring to them as ham. Okay, so spam and ham. So to enable this study, we essentially use the tools I was just describing you to just start collecting some WhatsApp data. So what we did is we selected around 5,000 Indian political groups. Now, you might be wondering why we focused in on Indian political groups. Well, the reality is that WhatsApp is hugely popular in India, hugely popular. A big part of this is the simplicity of the app, but also the fact that for many networks, WhatsApp is 0 rated. So people can use it for free. So it's a super attractive way of interacting with your friends because it costs you no money. So India gives us a really nice vantage to how a large population use WhatsApp. And from these 5,000 groups, we collected about 2.5 million messages posted by nearly 200,000 users. So we got quite a large sample of how people were using these groups. And what we then did is we took 4 main languages, because obviously India is a multilingual country. and it has tens of different languages. We decided to focus in on the 4 most popular one, led by Hindi and English, which covered about 75% of all the messages that we saw. And what we then did was filter out some of the simple boilerplate messages like hello and hi, just to simplify the data set. And what we then did is we started clustering similar text and images together into groups, which we refer to as clusters. And we used this technique to be able to identify spam campaigns. Why did we do that? Well, what we tended to find is people would start distributing very similar messages across several groups. So this clustering essentially allowed us to identify similar messages that were being spread across different groups by different users to try and find which are the common spam patterns. Okay, and after we'd done this, we were left with about 766K messages that covered the 4 main languages. Okay, so we've got this large data set. The next challenge we were faced with is trying to identify the spam from the ham, which is not trivial because unlike an email study, we don't have existing classifiers that can allow us to identify what the spam is. So what we started off by doing is creating a ground truth data set. And to do this, we identified a set of users who were manually removed by the administrator from at least 2 of their groups. Okay, and our hypothesis was that users who are regularly removed by administrators are likely to be those distributing abuse or spam. And from this, we identified about 250 users, which sent a remarkable 68,000 messages. So these people were really, really active. And from these messages, we used a human, in fact, 2 humans, to manually annotate the most frequently seen messages as spam or ham. Okay, so they went through them manually, tagging them. And what we then did is we constructed a dictionary of words from that. So we extracted commonly occurring words, which occurred at least 5 times, and then we manually created that list to identify clear words that are associated with spam. And you can probably imagine the types of words that we were looking at, things like Viagra and the rest of them. So what we then did is we manually extracted all the messages from the remaining data that contained some of these spam words. And this led to about 295 spam messages and about 112 ham messages remaining. And what we then did was extracted about, I think, 10,000 of these messages randomly to do manual checks to make sure that this approach was working well. And what we found was that in the majority of cases, they were correctly identifying spam messages. So what I want to do for the rest of this presentation is actually just take you through a few questions, which we thought were interesting. And the first one we were interested in is who spreads spam? So what type of people are the ones disseminating these spam messages? And the first thing to point out is, well, it's not just individual phone numbers. What we find instead is that you get entire campaigns of messages being sent by many different numbers. So what you see here along the x-axis is buckets based on the number of messages in a cluster. So we can basically call a cluster a campaign. So that's a bunch of messages that are very similar. So over at this end of the spectrum, you've got very large campaigns where there's at least 1,000 similar messages being sent by a group of users. And down here, you've got much smaller campaigns where under 10 messages are being sent by a group of users. And interestingly, what you find is that these very large campaigns tend to have very large numbers of users in them. So in other words, these are coordinated campaigns whereby a large number of SIM cards are all sending the messages out. Now, interestingly, we get, as well as spam messages in these campaigns, we also get ham messages, because what you'll often find is people will, for instance, forward jokes that they find funny. Now, what you find is that for the ham messages, things like joke forwarding, the majority are smaller clusters. So the majority fall beneath 1,000. And nearly all of the campaigns that involve over 1,000 similar messages being sent are spam. Okay. So these large clusters of spam, of messages tend to be spam. And on average, the spam clusters tend to contain about 83 messages versus about 35 for ham. So in other words, when you're forwarding things like jokes to friends, they don't tend to go as far as when people are actively forwarding spam. And the reason for this is very obvious. It's because the ham tends to be just friends forwarding messages amongst each other, whereas the spam clusters tend to be active campaigns with people forwarding them with a particular goal in mind. Now, if you look at where these messages are being sent from, what you immediately find is that, unsurprisingly, the majority are coming from India. So along the x-axis here, you have the country codes of the numbers sending the messages, and the turquoise bars are spammers. And what you see is that the majority of the turquoise bar, so the majority, the largest share of spammers are based in India. Makes perfect sense, we're looking at Indian groups. But actually, if you look at the non-spammers, what you find is that an even larger proportion of them are based in India. What's much more interesting to look at are the outliers. The cases where a large number of people in a country are spammers, but a very small proportion are non-spammers. And the best example of that is Russia here. So you can see that nearly none of the spammers, none of the users in Russia are non-spammers. So there's very few Russian users joining these Indian political groups, but a huge portion of the Russian users are actually spammers. And we see very similar patterns for countries like Romania and Cameroon as well, where you get a very large number of spam users in those countries, but a very, very small number of non-spammers. So this gives you a flavor of where these spammers are coming from as well. So a next obvious question is, what type of content is contained within the spam? So you can see here that we've broken down the spam and ham messages into those that contain URLs, phone numbers, both URLs and phone numbers, and neither. Now, what we find is that in the case of ham messages, the majority of them don't contain phone numbers or URLs. And again, this makes perfect sense because the majority of ham messages are just people sending text or images. Interestingly enough, for the spam messages, over half of them contain a URL, and about 20% of them contain phone numbers. Only about 10% of all the spam messages contain neither phone numbers or URLs. So you can see immediately that the majority of these spam messages intuitively are including links into external resources to try and tempt people to click and follow up. Now, to give you a flavor of what type of links these are pointing to, this gives you the breakdown of the different topics covered within the spam messages that we saw. So for instance, you can see that the majority of messages are job adverts. And we saw this very commonly, people forwarding messages about how, click this link, join this service, and you can make money. We also saw some other ones, such as political surveys. They were very popular, as well as adult content. So people disseminating porn links to try and get people to come in. Now, what's even more interesting is to actually look at the breakdown of these different spam messages. Because for instance, in the case of job adverts, what you find is that the majority of them contain phone numbers. So they're not URL based, right? Their phone numbers are asking people to ring other people up. And in contrast, the unsurprisingly largely contain URLs because, of course, the URLs are asking you to click onto these platforms and earn money. Okay, I can see a chat message, so let me jump up. Oh, bye, John Luca. Okay. So next question. We know that the majority of these spam messages contain phone numbers and URLs. The next question is, what do they point to? So to get a flavor of this, we used the WebSense categorization of URLs to understand what type of content the URLs were pointing to. And again, what we've done is we've broken down the content into ham and spam in pink and turquoise. So what we find is that video links and shopping links are very common. And they're very common for both spam, but also for ham. But the majority of spam URLs tend to get uncategorized. So these are not things like YouTube links or links to shopping websites, they're uncategorized. So this kind of piqued our interest, and we decided to take a look at whether or not these URLs may be containing any type of malicious code or malicious activities. So we then ran them through the VirusTotal service. Some of you may have come across this before. It's a very nice platform that essentially allows you to use multiple antivirus engines without having to do much of the work yourself. And remarkably, what we found was that a quarter of all of the spam URLs we identified were tagged as dangerous by at least 3 antivirus engines. And that's compared to just 1.5% for ham. So what you find is that a lot of these spam messages are actually containing malicious links, which gives a strong incentive to be able to try and start moderating this. The only problem is, incidentally, that it's impossible to moderate the content because, of course, Facebook uses end-to-end encryption, which means that not even they can detect the URLs and filter them out. So the next question we thought that would be interesting to look at is how long does this spam actually circulate? So what we did is we took the first occurrence of a message and the last occurrence of that same message within the campaign and computed the difference between them. And we've done that for both spam messages and ham messages. And what you see here is a CDF showing the lifetime of both spam users and spam messages. And what we find, interestingly enough, is that spam messages consistently outlive their ham counterparts. So consistently, spam messages last longer in the system than ham messages. But interestingly, non-spammers, so the users who are not disseminating spam, actually outlast the ham users who do not. Sorry, that's the other way around. Non-spam users outlive the spam users. So in other words, spam campaigns last much longer than normal messaging, but normal users who do not participate in spam campaigns tend to survive in the system for much longer, okay? So an obvious corollary to this is, why do non-spammers live longer? Well, it's kind of simple to look at. So this table summarizes some of the actions that we were seeing performed by users within the groups. And this includes, for example, being added into the group and being removed. And what we found was that, first of all, the majority of spammers join via link. It's very rare for spam users to be added by the administrator. And if you start taking a look at the number of users that leave and get removed from groups, it's far more common for spammers to be removed from groups than non-spammers. And again, this makes perfect sense because obviously administrators seeing spam being disseminated might go on to remove those users from their groups. So this gives you a breakdown of the different type of actions performed on users who are spam users and ham users. So the majority of removals from the system are for spam users. So the majority of times when an administrator removes somebody from their group is actually one of the spammers. And very few of these spammers are added by the administrator. So in other words, the reason that users that don't disseminate spam live longer in the system is that obviously they're not being removed by the users. So to give you a flavor of how spammers try to avoid this strategy, what we did is plot a time series of the most popular spam campaigns. So I think this is the top 15. And each one of these is a particular spam campaign that we observed and monitored. And you can see here that the spikes are showing the number of messages being sent per day for individual spam campaigns. So for example, you can see get free win reward. This was a spam campaign which basically you clicked on some links and it was offering for you to make money. And you can see that during this period between February and March, you get a large number of those messages being sent. So interestingly enough, what we find is that under half of the days during a spam campaign are actually that active. Another way of saying this is that the spam campaigns are stuttered. They come in spikes, but then they drop off. So there are a few noticeable outliers here, like the Get Free Win Award and the Pay With Award, these big ones here. But the majority of them come and go. So for instance, here, you can say the daily free cash. You can see we've got some activity, then it drops off. Some more activity, and it drops off again. Now, the reason for this is that the spammers tend to come and go. And our best conjecture for why this is that they're trying to avoid removal. So this gives you a breakdown of the number of times a user has joined a group based on how many groups they've joined. Okay? And what we find is that for those users who join a large number of groups, they tend to join many times. So you can see that here. So in other words, they join and they rejoin again and again and again. Okay? So this process that we see very regularly, a user will join the group, they'll post some messages, and they'll immediately leave. And this means that the administrator can't remove them because they've already left the group. And what then happens is that user rejoins the group and sends the messages again. And this is a really clever strategy that we observe, because it means that the administrators can never block them, because they can only block them when they're inside the group. Okay, so the idea behind that previous segment was to give you a flavor of how spammers are using the WhatsApp service to disseminate these messages. So what I want to round off by doing is very quickly taking you through some possible techniques that could be used to try and identify and deal with these spam messages on WhatsApp. Now, this is really not trivial, because for better or worse, Facebook introduced end-to-end encryption using the Signal protocol a few years ago, which means that not even Facebook itself can look at the message content. So this, of course, makes the identification of spam difficult. So how does this work? Okay, well, let's imagine a traditional scenario where we have two users who wish to communicate. And you have an intermediate server operated by WhatsApp. So first of all, the message gets sent up to the server, very simply, and it then gets forwarded on to the other user. Now, the downside of this is that this server mediates all communications and can therefore log all the messages. And I, for one, would not be very happy about Facebook retaining that information about my communications. So what end-to-end encryption does is whenever these two users want to communicate, there is first of all a key exchange. So there's a key exchange in which these two users generate a shared key. And then before sending any messages, the first user encrypts it. And as that gets sent through the server and gets received at the other side, the user can use the key to decrypt the message and read it. But at no point can the intermediate party read that content. So that means the privacy of these two users is protected from snooping by the WhatsApp servers. But the problem is, of course, that no longer means that the WhatsApp servers can moderate the content or filter out the spam. So what we tried to do in the second part of this work is to build some simple spam classifiers that could maybe get around this problem. So let me just move that. So first of all, let's take the simplest scenario. Let's assume we do not have end-to-end encryption, so we can just run a typical text-based classifier on the server in the same way that you'd have on Outlook or Gmail. So we don't really need to do much ourselves here because there are existing tools that can do that for us. So we took SpamAssassin, it's an Apache service, and this is just an off-the-shelf email spam classifier. And what we managed to get is 87% accuracy, which, when you think about it, is actually pretty good. And for those of you who are interested in why this was so good, what we found is that in the majority of cases, it just relies on simple text-based content, right? So it has a clear understanding of what type of terminology is related to spam, things like get rich quick or Viagra, and it was just filtering out most of those spam messages, which on the whole did a pretty good job. But the problem is this just doesn't work, because in WhatsApp, the end-to-end encryption model means that the server cannot run something like SpamAssassin on the messages. So the next classifier we try to experiment with is working on the assumption that the text is completely inaccessible to the server, so it cannot look at it. But what we realize is that even though we can't look at the text content, we can try to build profiles using metadata about the users. So what we did was we built a metadata classifier, and for each user, we essentially built a profile containing a count of all the different actions. And when I say actions, I'm referring to things like the number of times a user joins a group or leaves a group, the number of times a user is removed from a group or sends a message. So this is a full set of the features that we use within this. And what you can see is fairly straightforward actions, which you could probably guess, like the left the group, added members, added by the admin, and so forth. And what we then did is train a random forest classifier to try and predict the presence of spam by a user based on these features. And what we actually found is that we could, in fact, improve accuracy. And to give you an idea of the importance, frequency of posted message and use of a non-domestic number were the most deterministic features, right? Because what you tend to find is that many of the spam users host huge numbers of content spread across large numbers of groups. Often it gives you a fairly good predictor of whether or not these users are participating in spam. But the problem here is that actually some of these features are still a little bit privacy compromising. So maybe I don't want the WhatsApp servers to know that I'm being added by a member, or maybe I don't want it to record the number of messages that I send. So still, even though this is better than the previous classifier, it still is problematic by allowing the server to record this information and do the classification remotely. So the third and final classifier we played around with was trying to actually run a classification engine on the end user's device. And the idea is that all the messages can be sent out to the users, and each one of them can locally filter any messages that they personally perceive to be spam. So what we did here was to combine the previous two classifiers. So we used both the user profile and the text-based SpamAssassin scores. And what we then did is, using a combination of these features, we trained a random forest model for each group on each device. Because the thing is, if you join a group, you get entire vantage on all the messages, on all the actions. So that means you can actually have a better and more informed understanding of the group than the server does, because the server can't see the content, whereas your device can see the content. And what we then got is about an 86% average accuracy across all these groups. The reason I say average accuracy is that we got wildly different performance based on the different groups. So this is a CDF of the performance scores across the different groups. And what you find is that for some groups up here, you get very high performance. So these tend to be the larger groups that give you essentially larger data sets to train with. Whereas for a subset of the group, about a quarter of them, you get very, very poor performance. And the reason for this is that by and large, these groups are outliers with very small numbers of users and very small numbers of messages. So the classifiers tend not to work as well. So moving into the future, it seems likely that we're going to need some type of hybrid approach where the training that comes from the larger groups can also be shared and provided to the smaller groups. Anyway, I realize I'm coming up a little bit towards the end of this session. So what I want to conclude with is just a couple of the key challenges that I think are interesting in this particular research space. So first of all, one thing to remember is that using this type of public group data is highly biased. Every single study that you'll ever read takes a small segment of the overall set of group data in the world. And from there, we try to generalize. But to date, we still have a very limited understanding of to what extent the groups, the small number of groups we're using, really generalize towards global behavior. And because of this, we only really have a low bound of activity. So for instance, I've been talking a lot about spam messages. It's important to remember these spam messages are only being shared in Indian political groups. So that might give you very little of idea of what's being shared in, let's say, sports groups common in the United States. The other thing to remember is that WhatsApp groups are independently managed by independent administrators, which means that different administrators might have wildly different policies for what they consider spam or otherwise. So when we're, for instance, looking at the counts of how many times an administrator removes a user, we can't compare the behaviors of different groups and equate them, because those administrators may be removing users in different ways. And last but not least, it's actually very difficult to definitively link any of these behaviors across platforms, groups, or identify causality. So again, we've been talking a lot about how, for instance, spammers have these clever strategies to avoid detection, where they come and they leave groups repeatedly. We're inferring causality for this, we're not proving it. So that's certainly an area of future work that we need to look into more. So to quickly summarize, in my opinion, WhatsApp is a major social platform, quite different from other ones like Twitter, and it's something that we need to study far more. And the reason we need to study it far more is because essentially it's dark, right? It's difficult to access, and there's a lot of stuff that goes on there that we don't understand. So for me, this is not a problem. It's actually a really interesting opportunity. And I'd like to see more people working on WhatsApp and other messaging platforms like Telegram. And in my opinion, further domain-specific work is needed. So there's been so far a little bit of work looking mostly at fake news dissemination and politics groups. I think we need to broaden the scope much more to look at all sorts of different domains and different forms of abuse, such as the dissemination of hate speech or coordinated attacks on WhatsApp. Anyway, thanks for listening. I think that takes me to about 45 minutes. And if you're interested, here are a few posts. Feel free to take a look, follow up with me if interested. And if you have any questions, I'm very happy to take them.
Okay, thanks a lot, Gareth, for the fascinating talk. So it's time for questions and answers, but before doing that, Antonis, please stop the stream so we can make a more closed Q&A.